I can start. Is that okay? Okay. So hello everybody. Today we'll be talking about BiDi-powered Selenium and how it shapes tomorrow's automation. Again, hello. My name is Puja Jagani. I'm a lead engineer at the open source team at BrowserStack. I'm also one of the Selenium maintainers, primarily working on Java and JavaScript side of things. I've just left a few links for a way if you have any more questions, you would want to reach out to me or have any more concerns or anything that I can help you with after this talk. So I just have left some details below. Today it's going to be, I think it's 40 minutes of talking time. So quickly, this is the agenda that we have for today, right? So like I said, today we're talking about WebDriver BiDi. That's the topic. But before we jump to that, it's important to understand what's currently present, which is WebDriver Classic. And then slowly iterate our way through as to why the WebDriver BiDi protocol is so important. And then move on to bust some myths about Chrome DevTools protocol and WebDriver BiDi. How are they different or how are they similar in their own way? And then comes the exciting time because you might get bored of listening to me for like 20, 30 odd minutes probably. And then so we move on to the demo side of things and we conclude with the part where I tell you how you can help us, the open source project Selenium, and how you can contribute to this journey of ours in any way possible. Excuse me, I have a little bit of a phlegm, so I might just uh, breathe in between while I talk. Okay, so let's get started with something called WebDriver Classic. Um, don't don't get worried about the term. I'm going to break it down for you. So, what is WebDriver, right? So today's topic is all around web browser automation. In order to automate your browsers, you need a program or an executable or a process that knows how to talk to your browser, right? When you're manually interacting with your browser, it's pretty easy. You click, you open, you interact, and that's all done. But when you want to automate it or do it programmatically, you need some kind of a support or some system or like I said, an executable that knows how to talk to your browser. Something that can drive the browser or drive the web, right? So that's where the name WebDriver comes from. So WebDriver is nothing but a HTTP server or executable or a process that knows how to talk to the browser, that knows how to give instructions to the browser, right? So when it tells the browser, hey, can you open this web page for me? The browser knows how to do it and gives an appropriate response. And that's exactly the kind of program you want to interact with while automating your web browser tests, right? Now, WebDriver is very specific to different browsers, right? So Chrome has its own Chrome WebDriver, Edge has its Edge driver, Firefox has a Gecko driver, Safari has a Safari driver, right? So this speaks a language that the own browser understands and it becomes browser specific. Now let's come to a point where you want to write automation tests or web browser automation tests. Typically, anytime you're writing a test, you would use an automation library or a testing library. Selenium is one such library, and so is Nightwatch, Appium WebDriver IO. All of these, they know how to talk to the WebDriver, right? But the way they talk to the WebDriver is in a standardized manner, and that standard is nothing but a protocol that is written down as something called as the W3 WebDriver spec. We call it classic now, but it's used colloquially. It's not a formalized term. So basically, it is a protocol. It lists down, in the simplest term, it lists down all the REST APIs that the WebDriver can understand, right? So if you go and say, hey, create a new session for me, WebDriver will understand that and tell the browser to do it. If you tell it, hey, can you open this web page for me? It will understand, tell the browser to do it. And same way, any sort of web interactions, any sort of digging in the DOM that you want to see, any kind of shadow tree elements that you want to see, all the interactions that you would need to automate your web tests, to test your website and web apps, it has those commands. But it's written in a standardized manner, right? So basically, what remains common is from the Selenium part or from the Nightwatch or any of the frameworks which knows how to talk in this WebDriver protocol, you can send out these APIs or commands, and it doesn't matter which WebDriver is on the other end. It's standard, it's a contract. So be it Chrome, Firefox, Edge driver, they will all understand what is being sent from this part of the chunk. Right? And from the other part, once it reaches the WebDriver, it has its own language where it talks to the web browser. For example, Chromium browsers, they use the Chrome DevTools protocol, their internal protocol to talk to the web browser at this part. And similarly, Firefox has its own. So this is the current state of existence as of today, right? So this is what we have as of today that's been implemented in popular tools like Selenium or any other tool that follows this WebDriver standard. Nightwatch uses this, Appium uses it, WebDriver IO uses it. There could be other frameworks as well that use it, right? So this is the state today. But one thing to note is that this is done over HTTP, and that to HTTP1. So it's like a unidirectional protocol. So you send a request, and then once it's received, it's done processing, sent to the browser, you get a response. That's exactly what happens with this protocol. So it becomes unidirectional. That's the current state. Just remember this, we'll link it later. Now let's come to a point as to let's discuss a little bit of web evolution, right? So I think when the internet was new, I think it was at the early 1990s. It was designed to provide information. It was designed to share out information in form of static pages. The content was more informational. It was just meant to consume by reading it and providing information. It was not very complex, partially due to the internet speed and the lack of resources. That's how it was designed. Um, the advent of technology and the boom, your websites got very complicated. And when I say complicated, there was a lot of dynamic content because now internet bandwidth had increased. You were downloading a lot of images. You had media player. If you remember something called the Flash player, so there was a lot of content that was getting populated. And if you move further down in the in the mid 2000s and beyond, came the age of social networking and your social media, which had really dynamic interactive apps, which required a lot of user interaction from your end. Like today, any forum, you can take Reddit, Twitter, any forum, there's a lot of interaction, parallel activities going on at any point of time. So that's how the web evolved, and that's how the complexity of the user applications evolved. But at the same time, testing needs also had to evolve, right? Because you're testing complicated or complex systems, the testing requirement also became heightened or increased. You needed more sophisticated testing, or you needed more detailed testing, or something that is fine grained, right? Simple user actions or gestures were not enough because now you had apps that could potentially run on your mobile, or you had apps that could geolocated websites, right? So if you're one part of the world, you might want to simulate how your website would look if it is accessed from a certain geolocation. So you wanted these intricate setting and the amount of network requests that are going through to get all this dynamic content. You might be interested in understanding what's happening at that point, and you'd want to test things very, very thoroughly. So this kind of needed more fine-grained control or fine-grained automation, or even low-level control from your browser. You kind of needed that, but that's not something that exists as of now. It kind of does, but that's not something that's primary as of now. So what next? Like I earlier mentioned, that when it happens, when we're talking about Selenium or the WebDriver, we're talking about a unidirectional communication over HTTP. You send a command, you receive a request. But to get something fine grained or more low level control, you might need certain events, you might need certain information from the browser as well. At the same time, you might need something that allows a little more faster communication and reduces the handshake and a lot of back and forth, right? So because WebDriver protocol is written in HTTP and not to HTTP1, that's a little bit of a limitation there. So you need something that can provide a bi-directional communication. So the next upgrade for this would be using WebSockets. WebSockets provide a fully bi-directional communication, a duplex channel, right? So a client can send a message to the server, server can push message to the client, and it can just happen at any time once the connection is established. So that was the need for something bi-directional, probably using WebSockets came into picture. But hang on, something like this already existed, right? I think this is something everyone has seen, but let me remind you, this is a DevTools window. So anytime you open a browser and you go to a website, and when you right click, you see the inspect, right? So if I do right click, I can see inspect. If I do it like that, right? So if I do right click inspect, I can see such a window open. That is a DevTools window. DevTools, again, let's break the term down, is nothing but developer tools. It is designed with a mind to debug your web application as you develop it, right? So you can debug your application. You can profile, you can make changes to your website and see how would it look in real time. So it's for the developer to see how their website will actually look and to make changes and to see if they're reflected and potentially debug the errors if something was not getting displayed as per their requirements. So if you go to any favorite browser of yours, right click again, you would have an inspect button and it would open such a window for you, right? So such a window in Chromium browsers, it uses something called as a Chrome DevTools protocol. Again, protocol is a standard. It's a contract that the Chrome has that while sending these commands to the browser, this is the information it needs to display. Right? So just a protocol internally for it to communicate. And DevTools protocol is actually very rich. When I mean Chrome DevTools protocol is actually rich. But it is designed with the intent to debug, instrument, and profile your website. So debug, you want to debug and step through and see what's happening. Profile, when I say profile, you want to do more like memory and performance kind of things, right? So this is what it is designed in mind of, keeping that in mind. At the same time, it's also tied to a specific version of Chrome. So each Chrome DevTools protocol is specific to a Chrome browser version at any given point of time. With a newer version, they publish new DevTools protocol. At the same time, there is no guarantee of any sort of backward compatibility. What's working in say version 1 point, say 127, it might not work in version Chrome 128. They do not give that kind of a guarantee. So it's a highly useful protocol, but the whole intention is as you develop the website, it can be used. But again, it's a very, very rich protocol providing lots of information. Just a simple look on the tab tells you this, and it is way more deeper than that. So while nothing existed to provide such rich information, a lot of tools adopted this protocol. So Puppeteer is a popular, again, test automation tool. It solely relies on Chrome DevTools protocol, or at least used to rely on Chrome DevTools protocol. And Selenium also adopted it till something better came along the way. But wait, what if there is something better, right? So what if there is something that combines best of the both worlds? What if there's something that does, or that gives you everything, that WebDriver specification or the W3C WebDriver that we spoke about on the first slide? It gives you everything that is as plus the benefits of Chrome DevTools protocol, the fine-grained low-level control that the Chrome DevTools protocol provides. What if there's something that encapsulates all of this but does it even better? And that's what WebDriver BiDi is, right? Again, this is a diagram that we saw earlier. It's pretty similar. It's not very different. It again has the component of WebDriver, which knows how to talk to the browser. But what's different is, think of the communication channel that they use instead of HTTP is what they use is WebSockets. So that makes it bidirectional. That is just one part of it. That means now the browser has to send something back. It can, allowing in more fine-grained control of things. And we'll see some examples down in a bit to understand why that's so important or how useful that could be. But think of WebDriver BiDi as an extension of the so-called WebDriver Classic. So it has everything that Classic provides, all your element interactions, getting all your elements, all the user action APIs, everything, plus more additional commands and events, right? So commands are something you instruct and an action is performed, and events would be something you could subscribe to from the browser end, and if something of interest happens, it will tell you. So it has a lot more things, but it's designed with automation in mind. It's solely, so it's not exactly something like a copy of Chrome DevTools as it is. Chrome DevTools has a very different use case, like we discussed earlier. It is for developer tools, but this is designed with automation in mind by the browser vectors. And the beauty of this is it is implemented by all major browsers. So it makes it a perfect cross-browser tool, which Chrome DevTools protocols, like the name say, wasn't. It was just very specific to Chrome and Chrome versions. So now that we know how we went from the current state to the upcoming WebDriver BiDi state, which is almost there, let's talk about the difference between Chrome DevTools and WebDriver BiDi. Sometimes these terms are used interchangeably, even in Selenium documentation, at least earlier. And there's some confusion or myths around how are these two different. So they both have their benefits, and they both have their limitations, but again, it's all very use case specific. Let's start with the simplest requirement, browser support. So Chrome DevTools only supports Chrome-based browser, so that is Chrome and Edge, and does not support other browsers. Firefox does support something from Chrome DevTools protocol, but a very limited functionality. And it was doing so for Puppeteer, and it's honestly deprecated its Chrome DevTools support, and it's scheduled to be removal. Um, I think after about a year or so. So that's how it is. All browsers do not support it. On the other hand, WebDriver BiDi is cross-browser, right? So it's browser agnostic. It doesn't matter which browser you are. All browsers support it. So it's a consistent language that your testing frameworks, or even if you're writing a tool, that will be supported. Stability. When I say stability, Chrome DevTools is tied to a particular version of Chrome. So with each version, there'll be a new DevTools protocol. So if you're using it, there's a lot of dependency management and internal update that you need to do, and plan your thing around it. Even Selenium, we every time a Chrome version is updated, we have to do a new release with the new DevTools protocol. With BiDi, it's going to be stable. Anyone who's used Selenium in the audience would have known that for years, even you upgrade the version, things just remain the same. They hardly break. And that's thanks to the WebDriver classic protocol. Similarly, BiDi is also aimed at to be stable and consistent once it's fully developed and adapted by all the browsers. Event subscription. Chrome DevTools lets you subscribe to events, yes, but only for a particular tab in a window, right? So if you're interested in some browser events in all the tabs or in all the windows or a subset of tabs, you don't have that kind of flexibility. With WebDriver BiDi, you have all the flexibility. You can subscribe to events from all the pages. So when you test, you might be interested in events. What happens when I click this and a new tab is opened and I want to listen to events in both the tabs? Or you, while testing, you might have a requirement that only I'm interested in events from this tab. Any flexibility you think of in terms of browser events, it allows you to subscribe as per choice. The use case. I think we mentioned this earlier, but DevTools is a developer tool. It does an excellent job in terms of debugging, in terms of doing your profiling, in terms of seeing how your website will actually look as you develop. But it's not the best automation support out there. But WebDriver BiDi is designed with test automation in mind, because that is the school of thought that all the people who developed it operated with, and it has a fine balance between what the browsers can expose and what is essential for automation. And last is complexity. Chrome DevTools again provides a rich set of functionality, but that also makes it very, very complex because it's primarily meant to be used internally by Chrome and they know how to handle it. But BiDi is not very complex. It's designed with the idea that anyone wanting to use BiDi for their automation needs, or even frameworks like Selenium WebDriver or adopting it, should be able to easily do so. And it's relatively simple to understand. Even if you go see the spec, you'll pretty much understand what the commands and events mean, right? So I think that's where we are with this. And I will quickly like to show a demo between the two in terms of CDP and BiDi, just to show how complex it will be just to create a simple session. Right? So this is the demo that I have. I'm trying to watch console events. I'm running a simple test. It's a test in the Selenium code base. If you see, I'm trying to highlight that I'm here. All we are doing is creating a session with the Chrome DevTools, establishing a WebSocket connection with it, and how many commands we need to do. Like, we need to send out just to do that, and how complicated a simple thing like creating a session is. Yeah, it's a pre-recorded session, so I'm just running a few things. We can see logs. Just let's wait for a bit till things are out and about. Okay, we're able to open a session and we're just stepping through it. And now when you see the console logs, if you can see the console logs as I'm highlighting in the video, you can see the list of commands that are sent out, right? So every time you see a send, we've sent a command to the Chrome DevTools to establish a connection. We have to send a bunch of commands just so that we can create a session with a particular tab in that browser, not even the whole of it, right? So there's been like 3 commands already that we've sent. So that's one. And now that's it. So we've sent a bunch of commands just to establish the session, right? And that's about it. Now let's move on to something where we do the same thing with BiDi. So now this is also a test for BiDi. Um, Again, it's just a simple test. And here all we are doing is trying to get some logging information, right? And again, we're debugging just to show you the debug logs to say how many commands do we need, or do we don't need any command to establish a session. Okay, we've created a session, and yeah, I think we don't have a special command for the session because it's not needed. And there you go. There is nothing so far. I mean, there's nothing that says related to BiDi session in the log so far. And then I move on. And yeah, all these are the actual subscription code. So the amount of commands sent to create a session are none, because with the new protocol, the web driver or the browser, they know which port to expose. And with a certain capability, it just tells you just connect to this WebSocket and send me your commands. We are good to go. That's exactly what has happened. So this is a striking difference in complexity between both the tools. Were used for automation purposes, right? Imagine you're running the same thing in a device farm and you're sending the amount of back and forth you would do to run one session in CDP versus BiDi, right? So it's designed with that thought. So just concluding this part where we say it's all about BiDi and just trying to convince the audience as to why it's the road to better automation or the future of automation. First thing, it follows standards. So when you follow standards, it makes you automatically cross browser support, right? So all browsers will support it. It's the recommended W3C standards. Uh, Browsers are in favor of this and they're all aligned with this. So all the behavior that's expected would be aligned, right? When you're like automation testing, it's backward compatible. So the way it's designed, it's going to be stable for a long, long time, almost till the end of time, unless something new comes up. So with every version, you don't have to update. With every browser version, you don't have to update how your BiDi protocol or communication will look like. It would just simply stay the same. And I think most of us here understand the effort it takes in updating our dependencies or anything, and how difficult that becomes sometimes given our situations, right? Um, Third part is it is designed keeping automation in mind. So the APIs and the commands exposed are all beneficial to design or to utilize for your web browser automation and testing the new complicated or complex application that we have today. Is thoroughly designed with that in mind. And that makes a lot of difference. That's why it's also a little ergonomic in design in terms of how easy it is to use and what the functionality is exposes. Fourth, it's an extension of the existing WebDriver protocol, which is already a standard. So there could be a chance that customers don't need to do anything. The frameworks that they use, for example, Selenium, WebDriver IO, even Puppeteer, they now use WebDriver BiDi or plan to use WebDriver BiDi. And yeah, for the end user, the experience remains the same. The frameworks do the heavy lifting of, translating things from classic to BiDi or doing only BiDi only connection. That's up to them. But for end users, for most of these frameworks, a lot of things don't even change because it's an extension. So it's already giving you what was existing with the WebDriver Classic and a little bit more to it. And you can also have an option of having only BiDi only session. What that means is you don't need a WebDriver anymore, right? You don't need to download it anymore. You can have a BiDi only session and talk directly to the browser, right? So that's beneficial. It's also designed keeping performance in mind. Like I mentioned, if you're running your tests in a device farm or in a cloud somewhere, it's designed that you don't have to do a lot of back and forth to achieve a particular goal. Logical commands are clubbed together to give you the results you're expected in common day-to-day automation scenarios. And that's not how it is exactly for Chrome DevTools protocol, because typically Chrome DevTools protocol and the browser, like the Chrome, they sit on one machine. So they can have a lot of back and forth, and that's not a problem. That might not always be the case, right? You might, like I said, for a BiDi only session, you might have a browser in the cloud and you're trying to operate something and connect with it. And it might be a long latency involved at that point. So it's designed to minimize that. and it is designed by a lovely set of WebDriver BiDi working group. They are folks from Selenium, they are folks from different stakeholders, they are folks from all the browser vendors. They come together, participate, highly, really nice set of people, very intelligent, coming up and designing this protocol with the whole empathy of what is actually beneficial to the users. At the same time, what is balanced to make sure the browsers are equally efficient by exposing this information. So now that I've rambled on for about 20 minutes, I think let me do a little demo time. I think it gets boring listening to someone go on about the theory without actually showing it in action. So we're going to be um, doing a few use cases. It's about, I think, 5 use cases. These are popular use cases. As we go through each slide, I will talk about why that use case makes sense in testing, a few sentences, and then we will see the code and how you can do that with Selenium. So logs. I think this is the very interesting one. How many times has it happened that you want to test and you want to know, oh, was this logged? And that becomes so tricky to do, right? Same thing with browsers. So every time you go to browsers, you have a tab where you can see the console logs, or you might see some like console messages or JavaScript logs or those kind of things. And those might be very interesting or required when you want to test something, right? Imagine you're opening a web page, you click on something and it throws a JavaScript exception and it's logged there, but there's no way for you to consume it was logged. But now with BiDi, you can consume it, right? And that makes your test very powerful. Now you can test edge cases. Now you can test that if I click this, an exception is expected to be thrown and I can check for it. At the same time, when you're testing something and you don't expect an exception to be thrown, but it did throw, that means you need to go fix your code at that point. So it can be beneficial in that sense. That's exactly what we see. So this is a simple log test that it's actually a part of the Selenium examples repo, right? So we have a repo, and I'm just showing the structure where you could find this. It's pretty easy to locate, and yeah. So it'll be under log test. That's the package structure where you should be able to find this example and go run it right after this if you would like. One caveat is this is just the basic setup that you need to do, where you do like Firefox options, and please remember to set the options capability, right? So in order to enable BiDi and Selenium as of today, you need to set this WebSocket URL equal to true capability. That's an indication of the browser that you want to do a bidirectional communication. So it will send you a WebSocket address to connect to, and Selenium will do the rest for you. Currently, this is not a default one. Selenium for 5 onwards, it potentially could become a default one. Initializing a simple Firefox driver, or basically again, a mechanism that knows how to use the Web3 standard protocol and go tell the driver, hey, can you go do this for me? Yeah. So that's the setup that we'll be using in all of our tests. And obviously, you're passing in the options for the driver that, hey, please tell the browser to enable BiDi for me. That's exactly what's happening. Now let's look at the website that I'm testing. So this is the website. It's a simple website on Selenium that we use for testing. And I will just let me showcase what this website has and what we're actually testing. So this is a simple website. It has a bunch of buttons. When you click, something happens. That's all it does. So let's open the inspect the DevTools window, right? Just to see what's there. So this is the DevTools window that we spoke about. It's a blank console. There are no logs, and we want to be able to consume what we see on the logs programmatically, right? That's exactly what we're trying to demo here at that point. Yeah. So when you click on the console log, you see a log, hello world. If I click, some action happens. There's a log that's expected. If I click exceptions, it throws an exception, and I see a log for it. And yeah, and I might click something. It generates an error with a particular stat trace to see exactly where it's happening if I want to debug more. Again, you could have a website that would just do this. This is just a simple website just to show how this would work. And that's the website that we're testing. Yeah, so I think what the result that we get would be mapped to an object in Java called console log entry, which is a simple object. And here you can see that in the driver, we chunked it, and you can just add a console message handler. And once we receive it, you can just check out what did we get as a part of that message. So now we register a handler, then we navigate to a page. We click on the button like I showed you previously, but now where do we click programmatically? And we just wait for the log to appear. And after that, we just quickly go over and see as to the log entry was what we expect it to be. And then we just remove the console log handler. Yep. And our test passes. That's, I think, the beauty of pre-recording the demos. But yeah. And I think now we do the same similar test for a JavaScript log entry or like a JavaScript error. More so, we're looking at the JavaScript log entry, but we're particularly subscribing to an error handler. So log entry would just again represent an object which would have the JavaScript log details. But here we want to check or add a handler for a JavaScript exception or an error, right? And again, we add a handler. Now we navigate to the website, find an element that throws an exception. Yes. And then pretty much wait for it. And again, check if it has the error that we were expecting. Or sometimes you might just get an error that you weren't expecting. You can design your test accordingly. Yep. And the test passes again. I'm guessing that is the beauty of how things work, right? So that's what we are looking. That's the logs part. Now let's talk about something called a script pinning. I don't know how many folks have heard about script pinning before. Script pinning is nothing but setting your website or running a JavaScript script in the browser every time a web page opens, right? So when you open a browser, open a page, you would want a certain JavaScript script to run at the beginning, right? And then and do that every time you go to a new tab. But why would you want that? Like, why would we need that? Um, it might be needed for something, a very simple testing scenario where you have a complicated website, and by running a JavaScript script, you want to bring it to a certain state before you start testing on it, right? You might want to skip all the parts where you're navigating through it and doing a lot of things, but you might want to bring it in a particular state that, okay, this is where it is, and I want to test it further. For example, when you're writing a test, you might want to run a script to bring it to a state, say for a shopping website, where you're able to do everything and add it to a cart. And what you want to test is what happens after that, right? So you're bringing it to a particular state. And that's why script pinning is so important, because what happens is it will send one command and pin your script for as long as you want. Otherwise, every time you run the test or every time for each test case, what would happen? You'd have to send this request over the wire. Again, when you're running it using cloud providers or on a device farm that's geolocated in a different continent, network calls and latencies matter a lot. So with script pinning, in your test setup, you pin a script so that every time a browser opens, it's there, or your tab opens, it loads it, you have it in the state, and then you can run all the test cases that you'd like. Let's see a quick demo for this as well. This one I'm showing you, it's in Selenium, but now it's in JavaScript. Again, this is again a part of our, I think as far as I know, this is part of an example repo, and this is the package structure that's on the site, but you should be able to go run it after this as well. So again, we have a before and after. It's just the basic setup that we have, very similar to what I showed. Now this is the important part, where we're running a test that you can pin a script, right? So the script that we are pinning, it's a simple API driver.script.pin and pin the script that you would like to say. Here we're like, every time I land on a page, just log hello for me. Again, it's a test. It's pretty silly. But I guess again, when you have a heavy website and a testing, you might actually find valuable use out of this. And then what we do is we pin a script and we ask it to, hey, can you log this for me? And then we just add a console log message handler that, oh, did I actually get this log? And just verify that, right? So that's what we're doing. And Yeah, this is the website that we're testing. It's the same one we had earlier, but doesn't matter because we're just going to the website. We're not doing anything to it. So this is the website that we have. And initially on console, there is nothing. Only if you click does something appear, right? But if you don't click, you're not getting logged anywhere. But if you pin a script, it will have to do it irrespective of you clicking it or no, right? So that's what exactly what you're going to demo next. Yeah, you can see we have it. We've not clicked any element and the test passes. Hey, but no one understands what happened, right? So now let's just debug it a little bit to understand exactly what happened and verify if it's actually running the way we would like. Right? So now we've just paused it for a bit. We just went to the page. We didn't click anything. And when you say console, we see hello. That's exactly what your pin script is doing. You say, when you open a page, go hello. If you open a different page also, it would just log hello for you. That's exactly what has happened. Then you can go ahead and just verify the rest of the things with you. Yeah. And another use case that will come is once you've pinned a script, you might want to unpin it. You might want to get into a situation where you no longer need it. So you pin a script and then you will want to remove it. So what we are doing in this test is we are pinning a script and we're adding a console message handler, but we're just keeping a count of how many times we actually saw a console message. So when you've pinned the script, you would see it, but the moment you unpin it, you won't see it. So total, you go to the website once, you can see it because it's pinned. You unpin it, go again, you won't see it. So two visits to website, but pinning is done only once, so you would see it only once since you unpinned it. Otherwise, you would see it every other time. And yeah, that's the flow of things. I will again quickly run it. Yeah, test runs too fast to understand what's happening. But that's exactly what we're going to do. Again, we're going to debug it a little bit. Yep. So when it's pinned, you can see on the console there's a message, right? So when you unpin it and you navigate again, you're not going to be able to see it. You unpinned it, you go again, you see on the console, there's nothing. Console is empty, right? That's what it is. Because you unpinned it. You've not. There's no pin script to run, and that's pretty much about it for this one. Now, another interesting use case that we have is DOM mutation. I think we are running a little over the time, but I think I have another 5 minutes to quickly walk through it. So DOM mutation is nothing but when you want to see different elements and how they would play around, right? So you want to, let me just quickly move to the part where we actually run a DOM mutation test. Again, I'm explaining the same thing. The DOM mutation is essentially when mutation happens to your DOM elements, what changes, and you want to observe it, right? You want to observe the mutations that have happened. And here we're running a quick test to do the same thing. This is a typical website that we have. And in the website, we're just seeing what it is. We're just showing you what the website is. Again, when you see the website, there is an element with the ID that says reveal. And if you click on it, and there's something called as a revealed, right? So when you click on it, it goes to revealed and style is display none. So you need to pay attention. There's input and the display style is none. But when you click on it, it changes. So now when you reveal an input, the display style becomes empty. Like there's nothing there. That's the mutation that has happened. And that's exactly what we are going to test. Right? So that's the website. I'm going a little quicker just because of the time that I have. Again, we're adding a mutational handler, very similar to what we've done before, and pretty much emulating the steps of going to the browser, finding element, clicking it, and getting exactly the result that we need. And when you click it, you see we found an element. Um, and yeah, yeah. So we go to the website, find the element, click it, and then you find the revealed element, which is actually mutated. right? That is where the DOM mutation happens. And you're just pretty much storing that. So if you see in the DOM mutation values, it tells you what was mutated, right? So when you revealed earlier, the value for old value was display none for that particular attribute. Current value is nothing, and the attribute under name that is actually changed was style. So it's telling you what has mutated, right? That's what exactly happened. Now I think this is a very popular one in terms of basic auth is a basic authentication that you would like to do, right? So anytime you have a website, they ask you for username, password. Often you have this, and people want to enter this. This is a sample website that I have, and if I enter a wrong password, it doesn't work. We are entering the correct username and password, and it works. This is the app. So we want to be testing that this is the value that we are getting from the test, and that's exactly what it does for you. Um, Here, what you do is you do netdriver.network, add a authentication handler. And in that authentication handler, you pass in something like a admin, which is nothing but a username and password for this website. And once it's done, you just simply assert that, hey, you have the proper credentials. There you go. That's all you need to do. This is, yeah. I'm just going to skip to the part where I run the test because now that I've explained what you're planning to do. And then we're just checking that that in the paragraph tag is where the value is that we should be checking for, right? So now we just quickly run the test, and there we go. It runs. So to do a basic authentication is just a 2 lines of your code, and you are good to go. I want to skip this one. So I think what I'm going to conclude with here is, sorry that felt a little rushed in the end. I thought it wouldn't take so much time. Demos is a part that I'm most excited about, but still, nevertheless, this is very important in terms of Selenium is an open source community. It's been around for like 20 years almost. It's 20th birth of Selenium in October. And one thing I've learned being a part of this community is all contributions are welcome. So there are multiple ways you can contribute to the community. The maintainers and my colleagues, they are really, really good people. They were very warm when I joined. They're very helpful, very intelligent people. And there are several ways you can come help contribute to this journey. And one is simply by running the code using our framework to test. If that's not what's possible, sometimes when you're running or even without it, you might identify a bug somewhere. So reporting a bug is also a great way to help us. That kind of feedback is super valuable, right? Sometimes when in your automation journey, you might have certain ideas that you think or like feature requests that might pop up in your head that you want to run by us. So feel free to share those ideas with us in any of our forums, GitHub, Slack channel where we hang out. We are more than happy to take a look at it, and you're more than happy to come join hands and contribute on your own. If you have any ideas and want to discuss further, you have questions, that also helps us think. And sometimes we find a bug in the process as well, right? One of the great ways to start in any open source project is documentation. So when you're using a documentation, or you can improve a translation or improve like a doc API, like a Java doc kind of situation, like API docs for any language, or write a blog post for us if you have some knowledge to share that's uh, of this domain and related to Selenium, or probably just simply make noise, right? You can just reshare that this exists for in your network so they know these kind of things exist. And not just Selenium, it could be for other tools like Puppeteer, WebDriver IO, the whole BiDi ecosystem that's there and will develop further. Just some important links. You can screen capture this. I'll just let it be for a minute before I wrap up. And you can just take it. The first one is just the tags. If you're looking for BiDi related issues to come contribute to. Second one is the BiDi spec. Remember, I told you the spec is not that difficult. You can have a glance. It is technical, but it's not too difficult to understand what's going on. Third one is something called as a web platform tests. Web platform tests are actually tests run by browsers to test different features. And so you can see what's implemented browser, what's coming, what's left, which versions have it, and things like that. so that you know, okay, this feature exists. And if Selenium doesn't have it, ping us, we'll implement it and you can go use it. The code examples link, right? So the code examples that I just shared, I have a doc link for it. And last is nothing but the chat room where you can find me or all of us. That's it, folks. Apologies for rushing a little bit in the end, but thank you so much. I think I'm more than happy for the opportunity I got at hands-on testing to letting me share my knowledge.